Everyone knows the sky is blue. But not everyone knows. Why is the sky blue? Why is the sky often blue? Not another color. In the Earth's air, there's a very thick atmosphere that covers the Earth. That layer of air is just a transparent color. So where did the blue come from? In today's video, let's follow the natural code. The reason the sky is blue. Visible light vis-a-vis visible radiation. It's part of the electronic radiation spectrum that humans can see. Light from the sun or an electric light bulb. It's called white light. Sunlight has 7G color. Red, orange, yellow, 6 blue, indigo, purple. Each color corresponds to a wavelength, frequency, and carry different energy. Purple light has the shortest wavelength in the visible spectrum. This means that the frequency and energy of light is the highest in the visible spectrum. Red light has the longest wavelength, the lowest frequency, and will carry the least energy. Light in the air. Light moves through space in a straight line, if there's nothing to disturb it. As light moves into the atmosphere, it keeps going in a straight line until you encounter small dust particles, or the gas molecules get in the way. From now on, what happens to light? It depends on its wavelength and the size of the objects it's projecting on. Dust and water in the air is larger than the wavelength of light. Visibility. When light hits particles that are larger in size, it's going to be reflected in different directions, or being absorbed by obstructions. Due to the different colors in the light, they're all bounced back from the particles in the same direction. So the light bounces off the particles. Is still white light and contains all the original colors. Outside of dust and water, the atmosphere also contains gas molecules. These gas molecules, it's smaller than the wavelength of light. Visibility. If white light hits the gas molecules, it's not as simple as shining in the dust or water particles. When light hits a gas molecule, part of it can be absorbed by gas molecules. Then, the gas molecules will radiate light in many different directions than the original. There's a partial concept here. It's because there are some wavelengths in white light corresponding to colors that are easily absorbed. Some other wavelengths are harder to absorb. In other words, some wavelengths as short as blue will be absorbed more than the longer wavelengths, like red. The above process is called Western dispersion. The phenomenon is named after its discoverer, John Rayleigh, a British physicist. In 1871, Kelly has come up with the scattering coefficient equation of an inverse scale with wavelengths of light. The symbol is lambda to the fourth power. In other words, the shorter the wavelength of light, it gets more scattered and vice versa. I was able to answer the original question. The blue color of the sky is due to Western glass scattering, because the wavelength of light is 100 to 1000 nanometers, larger than the size of the gas molecules, 10 nanometers. So we can apply the Western dispersion formula for light scattering phenomenon in the Earth's atmosphere. As light enters the Earth's atmosphere, most of the long wavelengths are not absorbed by gas molecules, so it can go through. A little red light. Yellow oranges can be affected by air. However, a large amount of short waves has been absorbed by gas molecules. The shortwave light is then absorbed, will be scattered outward in many different directions. Now the blue light will scatter across the sky. During the day, no matter where you stand and which way you look, some blue light. It's always focused on your eyes. So when you look up at your head, the sky will always be blue. If you pay closer attention, as we look closer to the horizon, the sky seems paler. That's due to get to your place. Blue light after being scattered, it's going through more layers of air. Part continues to be scattered in many other directions. Therefore, there's a little bit of blue light near the horizon. Move closer to your position, compared to the amount of blue light from the top of your head. Another point worth noting is for sure, if you follow here, you'll have questions about wavelengths of purple and even indigo. It's shorter than blue, so the sky must be purple. The answer is ready for you. So why is the sky not purple? That's the shortest wavelength. A cause is due to the activity of the human eye in seeing color. The human eye is sensitive to light, has a wavelength of 380,740 nanometers. There are 10 million cells in the normal retina, rotating light sensor, and 5 million cones detect out color. Each cone cell contains pigment to help respond to different wavelengths. There are 3 main types of autosomal cones, with short wavelength types, medium and long. We need to use all 3 of these cells to see the most accurate color. Each cone cell reacts at the maximum wavelengths of 570 nanometers for long wavelengths, 543 for medium wavelength, and 442 nanometers for short wavelengths. However, there are 3 types of cones. It can react to the number of wavelengths over large areas and cross-planting, which means that there's a 2-spectral case. Different can cause the same reaction on the cone cells. Two different spectrums, but they do the same thing in the cell. The cone is called the heterogeneous isomer. Back to the sky. When the sky is a mixture of blue and purple, the cones in the human eye will react, when you see this mixture, into a mixture of blue and white. And finally, the signal to the nervous system is blue. This is similar to the red mixing trick, and green to yellow. Although some animals look at the sky, it's not as blue as humans. In addition to humans and some kinds of primates, most of the other animals, there are 2 types of cones in the retina. So these animals, like birds, for example, you'll see the sky is purple. Why do we see the sun as yellow? On Earth, we see the sun in the daytime as yellow. If you go to space or to the moon, you'll see the sun as white. Why? It's simply because, in the universe, there's no atmosphere to scatter sunlight. On Earth, a few short wavelengths of sunlight, blue or purple, has been absorbed by gas molecules and remove out of light beam, direct from the sun to the human eye. Therefore, the other colors that appear together are yellow. Last at SAO, the sunset is red. When the sun starts to set, light need to travel a longer distance through the air before reaching the position you see. Right now, there's more light that gets reflected and scattered. The less direct light from the sun approaches to your location, you'll see that the sun is less luminous. Also in this moment, the color of the sun began to change. From yellow in the daytime, it starts to turn orange. and then red. The main reason is, although the amount of blue light is still scattered, as in the day, but scattered many times, it has to go through a thick layer of air to reach the human eye. Next to it, long wavelength cams. Yellow in the beam. It's getting a little bit more direct to your location. Long wavelengths have to travel longer distances than during the day to go directly to your location. There's only less scattered red light left, more direct to the eye. So you'll see the sky getting redder and redder after the sun has passed behind the horizon. We don't see the light of the sun directly, but if there are clouds up there, they'll reflect red light back down to the ground, creating a beautiful view of the sunset. We finally found the answer for the initial questions. In the midst of what seems obvious, like the blue of the sky, it hides the great secrets of nature. And it's the same when we listen to find out. The world around will appear with countless miracles that we never expected. Don't forget to like, share and subscribe to channels, not to miss the next journey. The blue sky seemed calm, but it's the same place. Sometimes there's a lot of rage. The surprise of nature. Have you ever seen ice stones falling from the sky? In the next video, let's explore together. Because there's hail. It's one of those strange phenomena, and most intense of the atmosphere.